and good morning, everyone. So my name is Markus Kissler-Patig, and I wanted to tell you a little bit today about the European Space Agency and about the science program of the European Space Agency. So the science program is about 10% of the European Space Agency. And what we do is actually, yes, we're flying through the cosmos, we're observing the edge of the universe, and if you actually want to send your code to the cosmos, I think we are the prime address here today. So who am I? I'm working in Madrid usually, so I'm here in Munich by chance, or almost by chance. I'm in fact an adjunct professor here at the LMU in Munich. I'm teaching astrobiology, so I'm a PhD astrophysicist. I'm not an IT specialist. I'm in charge of about 20 spacecrafts in the solar system, and my research is mostly about planetary destruction, which usually leads to a bit of confusion when I try to explain that to my neighbors, but that they go, you're in charge of a large fleet of spacecrafts and you're doing planetary destruction. So my kids start to ask me, but are you our father? So yes, I am. So I wanted to actually show you a little bit what we do and why we are actually recruiting and what the type of we are recruiting, who we are. I think that movie is starting. Okay, so this is movie starting. So this is a movie, and I'll talk over it. It's our Gaia satellite. So we send a satellite up. We decommissioned it now after 10 years, and it mapped the Milky Way. So what you see there, in fact, is not an image. It's actually one pixel. For every pixel was a measured pixel. That's a satellite we're doing, and you can imagine that there's a lot of IT and other things involved. In this case, we actually mapped for 10 years the Milky Way. We took a position and a velocity and the properties of 2 billion stars in the Milky Way. So you immediately see that, you remember that probably from school. The universe is big, our Milky Way is big, and when you try to measure all of it, then you are suddenly collecting a huge amount of data, and then you need to actually do something with these data. I see that you're all mesmerized by this Milky Way. I see it every day, so it's fine. But it's fun because once you have actually all these data in your system, you can actually do whatever you want with it. And one view that you never have from Earth, because we sit in the Milky Way, is once you have actually all the data points in your system, you can actually turn the Milky Way the way you want, and you can look at it from above. So that's the view from above on our Milky Way, after we measured it with our system. So this, I'm showing you this and all the streams and everything which goes around. If you're interested in astrophysics, I'm here all day, and I love talking about it, but come see me if you want to talk about anything else as well. I wanted today to show you a little bit what we're doing. This is one example. It's one of the missions that I'm responsible for, Gaia. It's one of the ones we love the most because it leads to a lot of publications by scientists around the world. It's in fact the most productive scientific mission ever, more productive than the Hubble Space Telescope that you might have heard of, that we are participating in as well, and the type of things we're doing. So what is this European Space Agency? You probably have heard about it, but maybe don't know exactly what it is. I'll give you a very short run-through so that we know what type of agency we are, what type of employer we are. We are an organization which has 23 member states. Most of them are from the European Union, but not all of them, and vice versa. We do everything which has to do with peaceful use of space. We have no military branch, and we're trying to do everything which benefits all from space. Our headquarters is in Paris, but we have another 7 sites in Europe. So you see them here on the map. We have 2 sites in Germany, in Darmstadt, where we do space communication. They operate a network of antennas around the world. In Cologne, we have a center which actually trains astronauts. We have a very large technical center in the Netherlands. So in Noordwijk, it's near Leiden, half an hour from Amsterdam. I personally work at the most beautiful site, which is in Madrid. So I sit in Madrid, but we're also in Frascati in Rome. We're also near Oxford, and that's where we are. We have about 2,500 staff members, about 5,000 people work on our different sites, and we shuffle about 6 to 8 billion euros. It's not a million, it should be a billion, sorry for that typo, billion euros per year. So I'm responsible for 600 million euros per year of these, so 10% about. So that's the type of site we are. So my office is actually there. So that's why I say, if you're interested in working for us, apply to Madrid. I can tell you it's quite nice. We have a little castle as well, running track around, our paddle courts. But we do serious stuff as well. I mean, we work actually pretty hard and usually more than 40 hours of work, which is our nominal time. You see that we have antennas on site because this site used to be also, we keep actually communicating with our satellites there. We have larger antennas than this as well. These are 10-meter antennas. We have a 30-meter antenna nearby. And then we have other 30-meter antennas distributed in Argentina, in Australia as well, because as the Earth turns, we want to continue to communicate with our satellites in March. So the type of jobs we're looking for here, of the 300 people that are working for me, 200 are actually IT specialists. And then we have about 60 scientists. We have one geologist as well, so I don't know if anybody of you is a geologist. If you have field experience on Mars, you're hired. Otherwise, most of the people working actually for the science department are IT specialists. What do we do as an agency? We really are active across every area of the space sector. We are world leaders in space science and technologies. We launched over 100 spacecraft since '75, which is when we were founded. So this year we celebrate our 50th anniversary. We have launched over 300 launches from our spaceport, Kourou. And the areas, how we divided the space agency are these color tracks, and I'm working on the red track. So if you look at the red track at the far left, you see science. We have human robotic explorations. So this is what I'm working in and what we are doing. But then everything in yellow is what facilitates what we do. So these are our colleagues who build for us the rockets that send the stuff to space, the operation network around the globe, all the technology to actually land on Mars and elsewhere. And then we have in green, all the people actually do applications, so space applications. Our colleagues from Earth observations, they look down where we look up. And navigation, which is all your tracking. You probably, colloquially we call GPS. GPS is the American system. Galileo is the European system. Your phone will probably actually have all of these. Connectivity, secure communication is stuff we do. Commercialization and space safety. So we have a planetary defense office as well. So all of these people are doing lots of things. I show you two highlights, my favorite. So typically you hear that space agency brag with having landed on the moon. The moon, which is nearby, that you can see, is not very interesting. We didn't land there. The European Space Agency, we landed on the moon of Titan. So the Titan is the moon of Saturn. Saturn has 60 moons. Landing on the moon nearby takes you 3 days. Flying to Titan takes you 7 years. It was much more difficult to land there than to land on the moon. So that's actually an artist impression, but here on the right, it's actually an actual picture. Titan is the moon that you see there next to Saturn. It's larger than Mercury. It has an atmosphere, so it was easy to land on because it has a parachute. I mean, you can use a parachute. But the next project, so which you are in time now to join us, is to land on this other moon. You see the little dot here on the edge, on the very, very right? That's Enceladus. Enceladus actually has an ocean below the ice crust and is one of the places where we think it's one of the best places to host life if there's life elsewhere in the solar system. So if you want to actually come with us to there, we are launching in 2040. We are arriving in 2050. But between now and 2040, there's a lot of systems to build. So the other thing which we are very proud of is we also landed on a comet. Nobody else did that. A comet we thought was just a dirty ice ball. In fact, it was potato-shaped, so that's a real image actually. Well, we placed the satellite in, but the real image of the comet there, it didn't look like what we expected. We wanted to actually land on it. Eventually, it was difficult. It was a 12-year journey to fly there. And you can imagine that actually it takes a lot of systems to get us to achieve these type of things. So, what do we need IT for? So you're looking for a job in IT. What can you do for us? We do IT in all kind of sectors, and I'm going to show you 3 big areas where we need people like you. Okay? So the first one is everything which has to do with IT on board of the satellite. So in the background, you'll see a movie running. That's the satellite Plato, which we are actually building right now. It's at the moment in an integration hall in the Netherlands, and we are launching it at the end of next year. So end of 26, early 27, it's going to be launched. And what you see there in the back of me is where we assemble the eyes with the brain. So the eyes are 24 cameras, which are this thing on the back there. which are going to look for exoplanets. So this satellite is going to actually look for about 1,000 Earth-like planets that we want to then study. And one of the big questions we have, of course, is, are we alone in the universe? And the box, the black box here in the front, is in fact the brain. So on board of the brain, so we need people who actually know how to program electronics on board of that brain. You will be actually parked at 1.5 million kilometers from Earth. So we need people who actually know how to actually develop communication systems. We have one problem, is to actually make sure that we have a mass memory on board which can host all the data. So if these are problems that you like to work on, you're welcome. The other problem is no matter how much actually we can store on board, we need to actually bring it down to Earth, and we have limited actually bandwidth. Right? So if you think you have a bad bandwidth at home, try to be 1 million kilometers from Earth. It's worse there. And so what we need to do is typically on board we pack AI and other ways to actually filter the data and to pre-select the data or to pre-process the data before we send them down. So if you're happy to actually develop an AI which can recognize which one is actually an Earth-like planet and which one not, which one should be sent down to Earth to be further investigated, and which one can be sent into outer space, these are the type of things we do on board. So lots of actually IT on board. The other big branch is everything we call uplink. So everything which happens on the ground before you send stuff up. So this is an image of Mars. In fact, I'm going to fly over Mars with you. That's from one of our satellites called Mars Express, which is orbiting Mars in the last 20 years. It has 10 instruments on board and what we call uplink. So this is no AI. This is actually the real images. It's taken on from it's a camera which is called the high resolution stereo camera on board of the satellite. So it does stereo images, and what we are looking at in this particular case, we have instruments on board like synthetic aperture radars, neutron spectrographs, etc., etc. We're looking for water below the surface. We are there since 20 years. We have mapped Mars with about 1 meter resolution, some areas with higher precision. We actually have mapped where the water is underneath, and the geologist, if there's a geologist here, is looking at where to land and where to actually build our next human habitable zone on Mars. So we do these kind of things, but to actually do all of this, we prepare all the observations on the ground. Right? You send commands to Mars, it lasts 20 minutes, even at the speed of light. You wait 20 minutes for the answer. And all the instruments on board, typically 10, are fighting for resources because we have a limited power on board. We have actually limited memory on board, and we need to actually code correctly and optimize who does what, who uses what type of resources on board, etc. So all of this planning is done on the ground. We have actually most of the software engineers working for me at coding these planning systems or running these planning systems. And then we're actually sending them first to an engineering model, see if it doesn't break anything. If it doesn't break anything, we send it to the antenna and send it to the satellite. So that's the type of things we do. That's everything we call uplink, making models. If you're mathematicians, we actually try to cartograph that to actually find good reference systems. We need mathematicians as well to actually do the flight dynamics, because actually in order to fly to Mars, Mars is easy, it's not too far away, right? It's just a next planet out, just left after Venus. But when we fly to planets like Mercury, where we need to actually slow down getting into the inner solar system, or we're going to fly out into the outer solar system where we don't have enough fuel to get there, but we need to slingshot around other planets. There's a lot of calculation, a lot of mathematical models to actually do that and constantly feed with new data. So the uplink is everything we do before, everything which happens on the ground before we send it up to the satellite to explain what we do and on board, and to tell it what to do on board. And then the third and the last thing I wanted to talk about is what we call downlink. So downlink is, you send all your commands up to the satellite did whatever it did, it's sending you now bound data. So this is a movie actually which it starts playing. Yeah, it's not. Yeah, it starts playing. Okay, so this is a map. These are data we collected from one of our latest satellites, which we launched last year, the year before last, called Euclid. And what Euclid does, it maps a third of the sky, but it looks actually deep into space. So it's trying to actually look at the edge of the universe. Most of the little dots you see there are not stars; they're actually galaxies. Some of them are nearby. Nearby is a few million light years. Some of them are significantly further away. Further away means hundreds of millions of light years, if not billions of light years. Okay? So you get these and you map the entire universe. and you're sending down data, and the data at the end that you are here on the ground are in the petabyte array, right? So you have petabytes of data. So we need people who actually know how to store this data efficiently, because what we do with these petabytes of data is we process them. So how do you actually get your CPUs close enough to the data? What is the I/O effectively? How do you actually store the metadata when you need to process data, which are all interconnected? How do you actually build systems which actually can very quickly access all of the metadata information of the data? I mean, to actually bring it to the CPU. What type of actually supercomputing structures do you need? When is it worth to go into the cloud? When is it worth to actually build your own hardware on the ground? What are the latest technologies to actually distribute all these tasks? What do you do then when over 1,000 users want to access your petabytes at the same time? So you cannot send your data anymore to the user, right? Unless you have a very, very fast internet. Right? So you try to bring the users to the data. So you start to build platforms, data platforms on top of your databases, and you need to actually bring the users there, and you need to actually structure and organize these platforms. So all of these things are the tasks which actually these 200 people that work in Madrid do. They organize this type of data and make sure that actually the scientists at the end can learn about dark matter and dark energy in the universe. So that's a little bit to give you an idea of what's happening downstream. Lots of people actually care about our archives or our data systems. Either the hardware is with us or we actually use the cloud. So how can you actually join and work for us? That's going to be the last thing I'm going to talk about. Essentially, these are all the branches in which we hire. If you brought your friend with you that is a lawyer, we might even hire a lawyer. We have a space lawyers. Space is almost Wild West, but we try to actually put some order in it. But essentially, I think for you interesting is in the engineering, we need a lot of software engineers, a lot of people who actually do AI and machine learning, because we have a lot of enormous amounts of data that we need to actually pass through or make sense of, which humans can't do anymore. If you're in science, applied mathematics, we love you. If you can fly us to Jupiter, that's we need people who actually can compute that. But just below that, it's Earth observations and environmental science. So if you're a geologist and you have field experience on Venus, that's perfect. Everything which is IT, because of course we have structured IT systems both on the ground to facilitate all this data management, but also on board of the satellites. So if any of that is stuff that you see yourself doing, if you like we do, to fly into space and to explore the solar system, come and join us. I think the best way you can actually access all of these jobs is jobs.esa.int, where you can put alerts and search for jobs. Otherwise, let me see if I can advance that. We have a flow diagram here. So you start at the top, and you can actually work yourself through. It's done by our HR colleagues, so I'm sure you can optimize that. So if you can optimize that, you're hired. So it tells you, have you a master? No, yes. Do you have actually a bachelor? No, yes. Do you maybe even have a PhD? How can you join us on entry type programs, which are all the yellow ones? We have an academy. We can actually co-fund research if you come for research purposes, up to staff positions or others. So this flow diagram, you can find it in that corner of the hall. I'll be standing there for the whole day. If you want to talk, come and see me over there, or if you have any questions right here, right now, I'd be actually happy to answer anything you might have as question here. All right, thank you very much.
I do think that finding people with field experience on Venus can be quite hard. Can't imagine that's not the easiest thing. Does anybody have any questions? I can come up to you with a microphone that I have currently in my hand, that will be in your hand shortly. But I understand if you may be a little bit shy, it's early in the morning, I understand. If anyone sees a hand, please scream at me, but I also have some questions. A question that I always wanted to know. Have you found life beyond Earth? And if yes, can you tell us that you did?
So, have we found life beyond Earth? I'm not allowed to tell you. No, we haven't yet. You can imagine that we would share that immediately. But that's indeed one of the most important questions that drives us at the moment. Whether it's the one I showed you, the Plato, which is looking for Earth-like planets nearby, that going in that direction. We want to find other planets beyond the solar system which are actually habitable and which we can study. And then missions like the Mars missions or the ones which are going to land on Enceladus, that's to search mostly also for life, because that's, of course, one of the questions that moves us scientists for sure a lot, but I assume you're interested in it as well, is are we alone or is there life elsewhere? So that's one of our big drivers. But the systems that we need to actually find life are super complex, and most of that is actually IT behind it. And so that's why we actually hire more IT specialists than we hire scientists in the end. Yeah.
If I work in IT and I'm like, but I kind of want to become an astronaut, could that happen if I apply at ESA and maybe at some point I'm in space?
Yes, absolutely. So you can join ESA as an IT specialist, and at the next call for astronauts, apply for astronauts. And in fact, we do always have a lot of applicants, internal applicants, who want to become astronauts. I didn't apply. I'm not interested in flying. And we typically have, it's relatively competitive, typically 20,000 applicants for 10 positions or so. But take your chance. If you want to actually join us as an astronaut, you can absolutely, as an IT specialist, become an astronaut. Yeah.
I have motion sickness. This job is not for me. Talking about how to apply. The thing is, I bet most people wonder, what do I need to know? Do I need to know specific stuff about space, or can I just learn it in the process? What are the requirements? What do you want people to bring with?
Okay, so that's a good question. So no, you don't need to know anything about space if you want to work for us. So in fact, you can, if you don't even know how to spell spacecraft, it's good. If you know how to spell Kubernetes, it helps a lot more than if you know how to spell spacecraft. Okay, so seriously, if you like what we do, you learn it automatically. I think the nice thing of what I get from the feedback from engineers is that you are around with scientists. Usually they're super passionate. And automatically the knowledge diffuses. So although you'll probably be coding in your corner or building a database, the Mars guy will be on your back all the time, and by the end of a few years you'll be a Mars specialist as well, whether you want it or not. Okay, so but you don't need to come with any prior space knowledge. You can just come as you are.
We now do have the chance still for a question. If anyone now maybe there's courage. Oh, 2 hands. I think I saw this hand first.
Amazing talk. Thank you very much. When you said science is 10% of ESA, I'm wondering, is it the workforce or the budget? Because in my mind, ESA was mostly science.
So when ESA was founded 50 years ago, nobody knew what to do in space. Okay, space was just this weird thing up there. So 80% of the agency was science, and 20% was people supporting science. But by now, space is a €1 trillion industry, and it has the space department continued to grow. So we are much larger than we used to be 50 years ago, except that everything else grew much, much faster. Right, everything which has to do with telecommunication, everything which has to do with navigation applications. So 50 years ago, we didn't have any GPS or Galileo system or GNSS, as there's a term for it, right? So now we're actually doing all that. We didn't have Europe didn't have any launcher program, or it was just in the infancy. We didn't observe the Earth. 50 years ago, we couldn't care less about climate change. Now ESA has actually the largest fleet of Earth observation satellites. So there are all of these sectors which grew much, much faster. And so that's it, that science continued to grow as a part of ESA, but everything grew so much faster than we are left with just being 10%. But we still have 600 million a year. So, and I would say not to play with, it would be too derogative to do very serious stuff. I mean, to actually build up the knowledge base for humankind, to actually understand in which universe we live, to explore the solar system. but that's more than we ever had, except that everything else became also so much more important. When you join ESA, I would say, we're 10%, so 10% of the jobs are in science. The other 90% are not less interesting. Doing actually secure communication with space, which is super important at the moment, is super interesting as well.
Does it work? Yes. Yeah. Thanks for the awesome talk.
If you speak right into it, very close to your mouse like that, then it works.
Okay. Now? Okay. Thanks for the awesome talk. So how did you end up at ESA? So what's your career path?
Oh, so what's my career path? Okay, so as a student, you want this in 30 seconds, but it's very bizarre. I don't think I'm the right. So I went to university to become a student physics and physical education teacher. But I worked as an illustrator doing graphic design, and I thought that this would be my job. Okay, but then I was interested in astronomy as well, and I ended up finishing with a PhD in astronomy. So I had a PhD in astronomy. I worked in California for the University of California Observatories. I worked for NASA for a little bit. I got my PhD 30 years ago almost. So I'm older than I look. I was a pure academic researcher at the beginning, but then I joined the European Southern Observatory, which has headquarters here in Munich and operates telescopes in Chile. And I built actually cameras, so I did an engineering job for a while. Then I became one of the co-responsible for the European Extremely Large Telescope, so the largest telescope built on the planet. So I was a co-architect of that here. I started to do more and more technical jobs. I got then hired again over the ocean to work for an international organization in Hawaii, which operates telescopes in Hawaii and in Chile. I was the director of a large research infrastructure there. Came back to Munich in 2017 and was the associate director for science at the European Southern Observatory here. In 2019, I left and I decided, somebody told me, you've worked enough on the ground, don't you want to do space stuff? And I said yeah, space is pretty cool, okay? So 6 years ago, I moved to Madrid and I'm now happily working in Madrid. Still doing some research, I'm still teaching astrobiology here, so life in the universe, etc., for which I'm not paid. My day job is really to actually care about scientists, supervise engineers, make sure everybody is happy and everybody actually stays cool, and that we are on track to actually find life in the solar system. So you can see that I started in completely different direction, was mostly on the science side, did a lot of engineering, management, project management, and eventually after 30 years of career, end up being in charge of a fleet of spacecraft. Yeah.
I'm still hung up on how you just ended up with the PhD. It just happened. It's just something that accidentally happened.
Yeah, well, I think if you're so passionate, it works.
I don't have a PhD. If you guys
come join us. We have PhD programs.
Yeah, but I don't think that's not the only thing I need for a PhD. But thank you so much again. A big applause for you.
Thank you very much.